All right, so some of y'all are having trouble with level 17 intermolecular forces. So here's how we're going to do this. I want to look at the different types of bonds. I've got hydrogen bonding, dipole-dipole, London dispersion forces. So this is going to be a very polar molecule. Remember, with hydrogen bonded to H, right? The hydrogen that's H bonded to N, O, or F, or like we like to say, F, O, or N, because hydrogen just wants to have fun. So let's take a look at that one first. One of the obvious things that you want to think about hydrogen bonding, the first thing that comes to mind is probably water. So I can put an oxygen here. Okay, I'm going to bring a hydrogen down here. Bring another hydrogen down here. And indeed, now we have see more negative regions, more positive regions. And let's test this. Bring them together. Yes, indeed, they do have hydrogen bonding. So we'll put those together. Let's look at dipole-dipole. What are some things that could be dipole-dipole? Well, I can see that one side's going to be more positive and another's going to be more negative. I can already see that they're asking for 4. So that tells me we're going to need carbon in the middle. All right. So which carbon do I want to use? I'm going to use this carbon as my, so it's going to set up my 4 regions here. 1, 2, 3, 4. At least creates 4 circles for me. Sorry, I didn't show you all that on the other one. And now the question here is, which ones do I want to put in place? Well, these are going to be more negative. So let's go ahead and drop these fluorines in here. That's probably a good idea. All right. And that'll help us. Well, if we notice as we're working here, there's nothing else that's going to work here. Well, what does this tell us? This tells us this is probably wrong. And so we're going to blow this away. We're going to realize we're going to have a region up here of 3, of a positive here, a region here of negative, another one negative, another one negative. So what's another alternative? Remember, this is just problem solving. This is what this game's all about, is coming up with alternate solutions. So I'm going to put this chlorine back, put this whole thing back, put all of them back, and look and see what else we could put down there. Well, how about I put nitrogen here? And now the question is, do I want the traditional arrangement like we usually, with the 2 here and then 3 individuals? Well, yeah, we're going to need to have that, so I'm going to double click on that. Given the pieces that are left, what are my possible choices? Well, I'm seeing 3 here. These are all going to be negative, so that's what I'm going to put here. Is 1, 2, and whoops, and 3. And this checks out, and so now I'm going to test it and see if those go together. Are those dipole-dipole? They are. And finally, we're going to put this together. I've got a carbon. Now this one's going to ask you, well, which ones do you want? I'm going to choose that one. Put one oxygen here, the other oxygen there, and then we're going to test that. Notice it's kind of bouncing around. What's this tell me? Well, this is illustrating the temporary dipole, the London dispersion forces. So carbon dioxide, if you remember, has very weak attraction, London dispersion forces. So let's put those guys together. Very good. So remember, this is a game that we don't want you getting frustrated with, which is problem solving. So just like I showed you here, oftentimes you'll put things together, you'll need to take them back apart. So hopefully that was helpful.